Modern particle physics operates as a search for missing ingredients. We look for dark matter, superpartners, and new fields to force the equations into balance. Acts a correct global topological domain. When form precedes function, the geometry of that domain dictates the forces and masses we observe. This follows the historical precedent set by Euclid, who proved Plato's observation that only 5 solid shapes can close perfectly in 3-dimensional space. The geometry itself creates an absolute limit on physical possibility. This foundational framework explicitly maintains the Standard Model and Einstein's field equations. The existing laws of physics remain unchanged, but they sit within a specific global structure. The fundamental reality moves from the particle itself to de Broglie's wave. Matter emerges as a secondary effect, appearing only when this underlying wave is sampled at a specific position. Mode identity theory aims to derive physical constants and forces by reading their values directly off a single definitive shape, eliminating the need for free parameters. The theory rests on one topological postulate: a temporal edge bounds a non-orientable surface embedded in a closed space. The outer layer is S3, the only closed 3-dimensional space with no boundaries and no holes. It serves as the smooth substrate for the entire system. Inside S3 sits the fundamental structural layer, a single Mobius strip scaled to the size of the universe. This provides the non-orientable surface where the physics is actually read. The boundary of that strip is S1, the continuous temporal edge where time advances as the phase of the cosmic wave. Because S3 is closed and lacks any external boundary, the manifold triad represents the terminal limit of the framework. There is no outside to observe from. The Mobius surface introduces non-orientability into the vacuum. This single geometric property dictates the behavior of all matter. Under Z2 holonomy, a normal direction carried once around this surface returns reversed, creating the geometric origin of fermionic matter. This reversal requires 2 full traversals to return to the original state, enforcing a 4-pi period and an anti-periodic boundary condition. This anti-periodic condition makes the constant mode, where the frequency is 0, mathematically impossible. The wave cannot sit still. As a result, the allowed modes are forced into a half-integer spectrum: 1/2, 3/2, 5/2. The physical field couples to the orientation structure of the surface. Matter is fermionic because it inherits the rotational requirements of the Mobius shape itself. The spin 1/2 nature of matter is a direct consequence of living on a one-sided surface. The observable universe resides on the Poincare homology sphere, a discrete manifold built upon a smooth substrate. This domain is defined by the binary icosahedral group, which reaches a terminal order of 120. This establishes a maximum resolution of exactly 120 face positions on the cosmic grid. While fermions interact with all 120 positions, observation squares the wave function. This erases the anti-periodic sign and projects the 120 grid down to a 60-position grid for photon-mediated observables. Stability on this grid is determined by Hurwitz's theorem. The golden ratio is the hardest number to approximate by a fraction, meaning a phase stepping by this value stays furthest from rational traps. Simple rational steps hit the exact same grid positions repeatedly, creating a destructive interference that washes out the entire wave. Because Fibonacci numbers are the best rational approximations of the golden ratio, nodes at Fibonacci positions avoid these cancellations, serving as the only stable wells for an observable to inhabit. The continuous cosmic wave is thus forced into these specific stable slots, mapping abstract symmetry directly into physical anchor points. The scaling law shows that every constant is one quantity sampled at one position on the grid. The dilution factor represents the geometric price of sampling a value on the edge or surface of the geometry rather than at the Planck floor. The manifold index determines the magnitude. Edge quantities, which involve an evolving phase rate, take an index of 1 and dilute by a factor of 10 to the 61st power. Surface quantities take an index of 2, diluting by a factor of 10 to the 122nd power. The cosmological constant resides at this surface index. Its observed smallness is a direct result of its position in the geometry. The leading digits are determined by the phase operator. The cosmological constant sits at node 60, the center peak with zero slope, making it topologically protected. Meanwhile, the Hubble rate and Mond acceleration scale occupy the steep slopes of Fibonacci wells 34 and 13. These small constants are exact, predictable dilution factors derived from specific coordinates on the manifold triad. Fundamental forces are defined by pairing a carrier grid with a target grid. Electromagnetism pairs a bosonic carrier with a bosonic target, filling the 60 to 60 slot. The strong force applies a bosonic carrier to confined fermions at the 60 to 120 position. The weak force involves a spinorial carrier acting on fermion transitions at the 120 to 120 slot. This leaves only one remaining slot, a spinorial carrier acting on a bosonic target. This specific transition requires a fermion to become a boson, the core requirement of supersymmetry. Because the bosonic squaring projection is non-invertible, the topology forbids this transition. The topological pathway running from the spinorial grid directly into the bosonic grid is completely and permanently closed. Supersymmetry remains a structurally closed chair at a table set exclusively for 3. Mode identity theory creates an overdetermined web where all constants lock to a single hierarchy variable, omega lambda. Measuring just one calibrates the entire system because their ratios are geometrically fixed. We test this using the measured fine structure constant to determine the geometry scale. This single geometric input predicts the cosmological constant to within 24% of its observed value. By comparison, quantum field theory overestimates this same value by 120 orders of magnitude. Mode identity theory locks physics into a parameter-free architecture, where one measurement maps the entire universe. The universe is a static structure, defined entirely by its shape. The forces and masses we measure are the geometric costs of sampling the cosmic wave at specific topological coordinates. Cosmic time and evolution represent the observer's phase advancing along this static manifold. The hierarchy of nature is a finished accounting problem. Topology holds. The wave is. The particle samples.